Hi everyone, the question is the minimum value of the expression mod z plus mod z minus 1 plus mod z minus 1 minus iota plus mod z minus iota, where z is a complex number and iota is equal to under root minus 1 is. So as we solve this question, first of all try to understand that mod a minus b essentially represents the distance between the points that these two complex numbers a and b represent on argand plane. So having said that, mod z minus 0 is essentially distance just give me a moment, distance of the point represented by this complex number z from a point representing a 0. Mod z is mod z minus 0. Similarly, mod z minus 1, so it represents it is equal to distance of the point representing complex number z from the point representing complex number 1. All real numbers are complex numbers. Similarly, mod z minus 1 minus iota, so it is like 1 comma 1 point, so to speak. A real part is 1, imaginary part is 1, and here mod z minus iota, so you may just consider iota, and mod z minus iota is essentially the distance, so to speak, between z and iota. You understand, right? So here if you see carefully, these 4 points form a square. Yep. And since we want a minimum distance from z should be such that the sum of distances of the point representing z from these 4 points should be minimum. Yeah. So let me consider this expression in this way, mod z plus mod z minus 1 minus iota, or you may say z minus 1 plus iota, plus mod z minus 1 plus mod z minus iota. Yeah, and let me draw diagonals of this square. Now mod z plus mod of z minus 1 plus iota, it is essentially the sum of distances of z. Let me not repeat this phrase again and again, point representing z. Let me just directly say z, and you understand, right? So mod z plus mod z minus 1 plus iota is essentially the sum of distances of z from these 2 points. And I can minimize it by taking z to be any point on this line segment, on this diagonal. Yeah, it's very easy to understand. Let me explain this concept also. Suppose there are 2 points, let's say A and B, and if I want to choose C in this plane such that AC plus BC is minimum, yeah, then that C has to be any point on this line segment AB only, including A and B. C can even be A or B. How to understand this? If you take any point on this line extended, that means here or here, yeah, definitely the distance would be what? It will be more than AB. Why? Because let's say if you take a point on this line extended here, let's say C1, then BC1 itself is greater than AB. But if you take any point on this line segment AB, let's say this point, let's say C0, AC0 plus BC0 is equal to AB, the length AB, right? And C0 can be any point on this line segment. Now you may say, sir, what if I take a point not lying on this line segment AB, also not lying on this on the line where you extend AB, somewhere here? Then also, if you see carefully, let me call this point to be C2, AC2 plus BC2, AC2 plus BC2. As per triangle property, sum of 2 sides will be greater than the third side. So still so that means unless you take a point on this line segment AB, AC plus BC would not be minimum, and you can take any point on this line segment AB for AC plus BC to be minimum. I hope it is clear. So similarly, for this to be minimum, you can take any point on this diagonal, let me call it as let's say O, X, Y, Z. So you can take any point on this diagonal OY. Yeah. And similarly, mod z minus 1 plus mod z minus iota is essentially the sum of distances of z from this point, from point x and point z. So for this to happen, based on what we have just now understood, z can be any point on this line segment xz for a value of this expression to be minimum. Now both these expressions are adding. So to minimize both, if I can get a common point, on OY and XZ, I've solved the question. And we have a common point, which is the point of intersection of these two diagonals. Yeah. If you take Z to be, a complex number representing this point, then both these expressions would be minimum. So we are done. This essentially, you may say, the sum of distances, which is essentially the value of this expression, would be what? Would be essentially, let me call this point as, let's say, t, would be ty plus tz plus ot plus tx, which is essentially sum of the diagonals. Now the side length of this square is 1 and each diagonal is of length root 2, and sum of the diagonals will be what? 2 root 2, which will be the value of this expression, which essentially will be effectively will be the minimum value of this expression, which is what we want. 2 root 2 is the answer. B is the answer. Thanks for listening.